Good day, students. Welcome to the next lesson of our number patterns and recursion topic. We're up to lesson 4 now, and for today's session, we're going to be covering geometric sequences. But on top of that, we'll be reviewing what we've learnt so far with number patterns and recursion. But this is our main part of this topic, the geometric sequences. So if you haven't watched the previous lessons, I really recommend that you do. So that they will help with understanding what you're going to be covering for this topic. So the previous chapters that we've done were, I believe, 8B, 8D, 3M, and 8H. So make sure you do those questions and watch those videos so that you can make sense of what we're doing for this part of the topic. And this is one of the last parts that we're going to be learning as well. So if you're not up to date, please make sure you're up to date with it. Remember, all of our videos are available on OneNote. So all the video links are here, and also on the YouTube channel Cornrad. So make sure you please look in the YouTube videos and watch those videos so you're up to date. All right, let's get to it. So our learning intention for today is to be able to understand a geometric sequence. And we've learned some sequences already, one of them being arithmetic, and the other one is what I've highlighted just then, the geometric sequences. And also another intention for today is for you to understand what a common ratio is. Okay, that's another key word or key term in this part of the unit, and how you can use them, the common ratios, to generate a geometric sequence. And in terms of our success criteria for today, I'm hoping that you're able to, by the end of the lesson, calculate a common ratio, okay, of the geometric sequence, generate your terms of a geometric sequence, and graph a geometric sequence. Okay, those are three things that we need to be able to do by the end of today. Calculate the common ratio, generate a sequence, and graph a geometric sequence. All right, so before we get into geometric sequences, we need to firstly do a quick recap of what we've done so we can get familiar with sequences. So if you haven't watched those videos, this might help in some ways to as a bit of a introduction to the previous sequences that we've learnt about. So please make sure you're paying attention, but also watch those previous videos. So remember what a term refers to. So a term is basically the name of a number in a sequence. So T1 refers to term number 1, or the first number. T2 is term 2. T5 is the fifth number. Okay, and we know that in a sequence, like I said here, T1 here is the first number, so in this case it's the number 4. T3, which is the third number, is 16. T5, which is the fifth number, is 28. You also see that A is used in replacing T1 as well. So you will see the letter A, and it represents the first number in a sequence. Okay, so this A comes into play when we write recurrence relations and the nth term rule, which we did learn about in the previous lessons. Right, so moving on. More of a recap. Remember that your arithmetic, sequences are basic. It's a type of a sequence where the numbers either go up or go down by the same amount. So just keep that in mind. Don't forget what this means. Arithmetic sequence, you're either adding or subtracting by the same amount. Okay, so arithmetic, adding or subtracting by the same amount. And we know we can see the pattern here for this sequence. It's going up by 7. And in this sequence, it's going down by 3. So for both of those sequences, they're both arithmetic because they're going up and down by the same number. And that same number that we're going up and down by is called the common difference. So remember that. In this sequence here, I can see that it's going up by 5. So the common difference is positive 5. And in this sequence, it's going down by minus 4. So the common difference is negative 4. Oh, before I get to that, actually, sorry, if you forgot how to calculate or find out what the common difference is, it's really easy. There is a rule that we use. So you can write this in your notes if you like. So the common difference, okay, is equal to any term minus the one before it, so the previous term. So I could go, for example, in this, let's go with this example. I could go T5 take away the one before it, which is T4, so 17. So 22 for this one, 22 take away 17 is equal to positive 5. Okay, so the common difference is positive 5. You can do the same here with negative. So I might go T4, which is negative 3. Okay, take away T3. Sorry, what did I say? T4, sorry. Negative 3, take away T3, which is 1. So negative 3 minus 1 equals negative 4. So the common difference, negative 4. All right, so that's with our arithmetic sequences. Now with this new sequence we're learning about, which is a geometric sequence, it is somewhat different. Okay, so we've been learning about adding and subtracting by the same amount with our arithmetic sequences. But what about other type of sequences? So the next type of sequence we're going to be learning about is what we call the geometric sequence. So geometric sequence, okay, is generated. So it's a sequence again. So it's a list of numbers where the next term is generated. So you get the next term not by adding or subtracting, but by multiplication, and not listed here, but by also division. But for now, we're just going to stick to multiplication. Okay, so the next term is generated by multiplying by the same number. So instead of dividing, we're multiplying by the same number. So, for example, in this sequence, let's look at that. You've got T1, which is 3, T2 is 6, T3 is 12, T4 is 24, T5 is 48. So in this sequence, we can see that the next term, okay, so the next number is twice the previous number. So if you look at 6 and 3, term number 2, okay, which is the second number, is double term number 1, which is 6. Cool. Term number 3 is double term number 2, which is 6. So that means term 3 is 12. That's it, it's double. And you can see the pattern. Okay, it is multiplying by 2 each time. Okay, so the number that we're multiplying by in this case is the number 2. So it's increasing by times 2. Now, that number, so we've learnt before with arithmetic sequences that the number that you're adding or subtracting by is called the common difference. Now, with geometric sequence or geometric sequences, we call it the number that you're multiplying or dividing by, but in this case, just multiplying. For geometric sequences, okay, so this only applies for geometric sequences. A common ratio is the number that you're multiplying by. Okay, so that's what's listed here. Now, what's the name there? Okay, the number you're multiplying by is called the common ratio. So if we look at these examples, okay, this first one here, we're going 4, 12, 36, 108, 324. Okay, well, from 4 to 12, it looks like it's times 3. 12 to 36 is also times 3. 36 to 108, well, let's test that. 36 times times 3 should equal 108. Yep. Times 3. And then 108 times 3 should equal 324. Cool. So that means the common ratio each time in this sequence is multiplying by 3. So the common ratio is 3. Okay, what about this one? Okay, what's this multiplying by? So 100 to 750, 750 to 562.5, and then 562.5 to there. Okay, what's it multiplying by? Or I can see, this is something that we need to understand. Whenever you're multiplying, okay, remember that if the number you're multiplying by is greater than 1, as you can see with this sequence here, it's going to increase. Okay, if the number or the common ratio you're multiplying by is greater than 1, it's going to increase. If it's less than 1, okay, it's going to decrease. So what this tells me is that the number you're multiplying by is going to be less than 1. Now, we don't know what it is yet. I'll tell you now, it's multiplying by 0.75. Okay, and we'll figure out I'll show you later on how to figure that out. But let's test my theory that this common ratio for this sequence is 0.75. So let's go 1,000 times 0.75 equals 750. Okay, 750 times 0.75 Yep, so that equals 562.5, as you can see. Okay, and then let's do it one more time. 562.5 times 0.75 and should equal, yeah, that. So it's multiplying, or the common ratio is 0.75 for this sequence here. Okay, so the common ratio is the number that you use to multiply to get the next term in a geometric sequence. Okay, notice how that's different to your common difference where you're adding and subtracting. All right, so how do you calculate the common ratio? Here is the formula that I'd like you guys to either note down or write down somewhere if you don't have the notes. Okay, either of these two are fine, they're the same thing. But the common ratio is calculated when you get any term and you divide it with the previous term. Okay, so it's any term divided by the previous term. Okay, that's how you get the common ratio. So let's test that theory here, or that formula. So you've got here a sequence, T1, which is 6, T2, 1, T2 is 6, T3 is 36, T4 is 216, T5 is 1296. So let's test the theory or the ratio of the formula. Okay, the common ratio, is any term divided by the previous. Notice how that's different to common difference, yeah? So instead of minus, this one is divided by. Okay, so for this one, let's go with, I might go with T4 and T3, okay? Because it's any term divided by the previous term. So in this case, T4 divided by T3, which would be 216 divided by 36, which equals, so 216 divided by 36 equals 6. Okay, so supposedly the common ratio for this sequence should be 6. So from there to there, you should be multiplying from 6. So T1 to T2, T2 to T3 should be multiplied by 6, so on and so forth. So let's test that theory, if that's the case. If the common ratio for this sequence is 6, so 1 times 6 is 6. 6 times 6 is 36. 36 times 6 is 216. And 216 times 6 is 1296. So that's correct. So the common ratio in this sequence is 6. Okay, so don't forget that formula of finding the common ratio. It's any term divided by the previous term. Okay, let's move on. So for this, I'd like you guys to try and do some of these as an example. Pause the video now and try these examples for yourselves, and then come back to the video and check your solutions. Okay, let's do the solution. So for these questions, okay, remember, just use that formula, any term divided by the previous term, to find that common ratio. Okay, so let's go with T3 for this one. So I might go T3. Actually, let me put up here the formula. Any term divided by the previous. Okay, so I'm just using that formula. So I might go T3 divided by T2. Okay, in this case, that would be, go down here, 225 divided by 150. Now, you can also guess, or not really guess, but also assume, or at least make some judgments on whether or not the common ratio is going to be bigger than 1 or less than 1. Remember what I said. If your values or your terms are increasing, your ratio is going to be greater than 1. But in the next example, if it's decreasing, it's going to be less than 1, so some sort of decimal. So in this case, your answer should be a number that's greater than 1. Okay, so let's put that in a calculator. 225 divided by 150, which equals 1.5. So the ratio should be 1.5. We can test that on a calculator as well. So if our first number is 100, we've done this before with our arithmetic sequences, but you can also do this on your geometric sequences. Remember, you can generate it just using your calculator. So if you write down the first number, which is 100, press enter, or equals, and then remember our common ratio according to this is 1.5, so times 1.5. If I press enter, there's term number 2, term number 3, term number 4, term number 5. So we got it right. The common ratio is, or should be, 1.5. Let's try the next example here for finding the ratio. So remember, look at the formula, any term divided by the previous term. So I might go with T2 divided by T1. Okay, so in this case, it'd be 28.8 divided by 34.56. Remember what I said? If your terms are going down or getting lower and lower, it means the ratio should be less than 1. So in this case, 28.8 divided by 34.56. 0.8333. Okay. Let's go 3 decimals. All right, so let's test this. If the common ratio is definitely 0.8333. So let's go 34.56 times, enter. So that's how this is how we generate on a calculator. And then times 0.833. So if I keep pressing enter, there's term number 2. Yep, so if I round that, it should equal that. Term number 3, again, if I round it up, should equal 24. Term number 5, 4 I think it was. And then term number 5. So we got it right, that's the common ratio. Or actually, if you got those as the common ratios, then you've done it correctly. All right, let's keep going. So remember what I did on my calculator, yeah? Because this is going to be useful for this part of the lesson, generating a geometric sequence. So remember, you can generate them, your geometric sequence by, similarly with what I did with the calculator there. So all you're doing is you're multiplying the current term with whatever your common ratio was. So in this case, we need to figure out what the ratio is because we don't know what it's multiplying by to get term 4 and term 5. Okay, so let's figure that out. Ratio, remember, any term divided by the previous term. So in this case, I might go with, I can see there's 3 terms that are given to me. I'll just use T3 divided by T2. So in this case, it would be 28 divided by 14, which equals 2 for putting my calculator. Okay, so that means I'm going up by multiplying by 2. I'm getting the next term by multiplying by 2. So let's test that. So 7 is my first term. Multiply by 2, because that's my common ratio. So if I press enter, I should get term number 2, which is 14. Term number 3, which is 28. So now I need to figure out what is term number 4. So term number 4, okay, is going to be 28 times 2. Okay, because I'm multiplying by 2 each time, yeah? Okay, so make sure you show you're working out like this. So in this case, term 4, let's press enter here, is 56. Okay, and then term number 5 is the same thing. It's going to be 56 times 2. So I see that. Term number 5, it's whatever term 4 was, times 2. So 56 times 2. Press enter on my calculator. 112. Okay, so you make sure when you do these questions, it's the same as when we were doing arithmetic sequences. You got to show you're working out like this. Okay, you have to show it. All right. Again, pause the video and try and do these questions yourselves. Make sure that you round your answers, as it mentions here, to 2 decimals when you do these questions. Okay, so pause the video and give these questions a go. And then once you're done, come back and we'll do the solutions. Okay, let's do solutions to this. So generate the next 2 terms in the following geometric sequence. So it already tells us that it's geometric, which is multiplying by the same amount. Okay, so there's 2 things that we need to do for these questions. Okay, we have to figure out the common ratio, and then from there generate the next sequences. Okay, so remember generate the next term. Sorry. So common ratio, remember, is any term divided by the previous. So I might just go 11 divided by, so I'm going T2, sorry, let me do the full steps. T2 divided by T1, which in this case is going to be 11 divided by 10. So the ratio is 1.1. So I'm multiplying by 1.1 each time. Okay, so that means to go from T3 to T4, I'm multiplying by 1.1. So that means T4 should be whatever T3 is, which is 12.1, multiplied by 1.1. Okay, so let's try that on a calculator. 12.1 times 1.1, which is 13.31. Okay, and then that means T5, so if this is 13.31, and I'm multiplying again by 1.1, that means T5 should be 13.31 times 1.1. Okay, so 13.31 times 1.1. 14.641. But we'll just round it to 2 decimals, so 14.64. Cool. Next one. Okay, I can see this sequence is going down, so that means my R value is going to be less than 1. So I might go with T3 divided by T2, so it's going to be T3 divided by T2. So that'll be 729 divided by 810. So 729 divided by 810. 0.9. So that means my common ratio is 0.9. So to go from T1 to T2, I'm multiplying by 0.9. And from T2 to T3, multiply by 0.9. So that means from T3 to T4, it's the same procedure, multiplying by 0.9. So let's figure out what T4 is. So T4 should technically be whatever T3 was. So I can see here, to get T4, I have to get whatever T3 is multiplied by 0.9. So 729 times 0.9 times 0.9. So 656.1. Excuse me for that cough. 656.1. Okay. And then to go from T4 to T5, I'm again multiplying by 0.9. So T5 should be 656.1 multiplied by 0.9. So that should be 590.49. Again, make sure that you round your answers to, as it says here, 2 decimals. So just watch out for that in the SAC as well, yeah, when you do these questions. Make sure you're rounding your answers to the decimals that it's stating. Okay. Let's go to the last part of this question, this topic, where we're going to now graph our geometric sequences. So we've done some graphing before on our tables. Okay. Notice how with arithmetic sequences and what we've learned about, with arithmetic sequences, that when we graph them, generally what you get is you get a straight line, whether it's a adding type of arithmetic or a minusing type of arithmetic. Generally, okay, when you're adding and subtracting by the same amount, okay, it's going to be a straight line. Okay, so see that's generally what happens when we do arithmetic sequences. But when it comes to geometric sequences, they're a little bit different. Okay, generally with arithmetic sequences, because you're multiplying or dividing, what will happen is the graph should curve. Okay, so it's either going to curve upwards like that, or it's going to curve downwards like that, or it might also curve this way as well. Actually, no, I think they normally curve that way. Okay, so it's going to curve upwards or curve downwards. That's what you'll normally find with geometric sequences. So if you're graphing something and you find that if you're graphing, for example, arithmetic sequences and it's curving, make sure you've checked if it's arithmetic or geometric, and vice versa. If your sequence is geometric and for some reason it looks like a straight line, You may not have graphed it properly. Okay, but just notice the difference between arithmetic and geometric graphing. Arithmetic sequences, straight line. Geometric sequences, curved line. Okay, let's test that. All right, so for this sequence, show the values in a table, plot the table on a graph, yeah, and then describe the graph. All right, let's do this. So, question A, show this in a table. We've done this before. Okay, the tables aren't that hard to do. Just make sure you understand it's an X and Y table like this, and you need to put all these numbers in that table. So, just make sure you've got enough space to put your numbers in. Okay, and we've got 5 values there. So, 5. Okay, up here on the top is your n, which is the term number, and tn is the term value. So let's put the numbers in. So you've got number 1, 2, 3, 4, 5, and the term value. So the first term is 7, second term is 14, 28 for the third term, 56, and 112 for the fifth term. Okay, cool. Now we're going to use the table to plot the graph. On the graph, make sure you understand where n and tn are going to go. When I say n and tn, where are these values going to go? Okay, so n should be on the bottom because it's a term number. Tn should go on the y-axis, which is the value of that term. Okay, so let's plot this. Term number 1 is 7, so the value for the first term is 7. So this is a bit tricky to graph, but I can see that this goes up to 50, then 100, so I'm assuming each of these go up by 10. So 7 should be about here somewhere. Value number 2 is 14. Okay, so if that's 10, that's 20, 14 will be about here somewhere, just below the 15 line. 3, 28, so again, 10, 20, that's 30. 28 will be about there somewhere. Oops, sorry. About there. Fourth value is 56, so if 50 is there, 56 should be about here. And notice again how our graph is curving upwards, and then value number 5, or term number 5 is 112, so that'll be about here. Okay, so notice now, if I was to put a line through it, it would be curving upwards, and that's the case. It's not a straight line, it's curving, because it's a geometric sequence. Now for part C of this question, describe the graph. We can just say the graph is curving or increasing, and it is curved. Normally you don't really see a lot of these sort of questions, but you can say the graph is curving upwards, the graph is increasing, and it is curved, as long as you mention those terms, yeah, when you do these examples or these questions. All right, your turn now with this question or this example. Go ahead and try it, pause the video, give it a crack, and then come back and watch the solution. All right, let's do the solution for this. So let's show the values in a table. So same deal as what we did in the previous one, yeah? All right. Question A, in a table, X and Y table. Make sure you give yourself space to write the values. There's 5 there, so 1, 2. Okay, like so. Remember, n is the term number, tn is the term value, and you've got 1, 2, 3, 4, 5 values. Let's put them in. So the first one, 200, 120, 72, 43.2, and then 25.92. Okay, let's graph this. So remember, n goes on the x-axis, tn goes on the y-axis, which is the term value. So the first number is 200. Let's put that in. 200. Number 1, 200. Number 2, 120. Well, I can see it's going up by tens again, so this should be 120 there. Value number 3, 72. So that would be about here. Number 4, 43.2, so that's 50, that's 40, so it should be about here. And then number 5 is 25.92, so if 25 is about there, it should be about here. Okay, so again, see how it's curving downwards because it's geometric. Okay, question C, describe the graph. So you say the graph is curving downwards. And that's really all I look for, I think, with these descriptions. Just write down whether it's curving up or curving down. All right, so just to recap before we finish up, the differences between arithmetic and geometric, so you understand them. Arithmetic sequences are adding and subtracting. Okay, so remember that. To get the next number, you're adding and subtracting. But with the geometric sequence, you're multiplying to get the next number or the next term. With arithmetic sequences, okay, the number that you're adding and subtracting by is called the common difference. Okay, but in geometric sequences, because you're multiplying, it's called the common ratio. So understand the difference between them. Okay, arithmetic sequences, common difference, add, subtract. Geometric sequence, it's just multiplying, so it's common ratio. And to find the common difference for a arithmetic sequence, any term minus the previous term. For a common ratio, to find the ratio, it's any term divided by the previous term. And just a bit of a note or a caveat here, not all sequences you see are going to be just arithmetic or just geometric. Some sequences will involve both a common ratio or a common difference. When I say both, it could be like times 2 plus 1, okay? Or it could be like the sequence could be like multiply by 3 and then minus 2. Okay, so there could be a mix depending on the pattern, but just understand that when you're doing these questions. All right, so these are the exercises that I want you to do. So 8E, questions 1, 2, 3, 4, and 5. Remember, for these exercises, they are in your notes, so just go ahead to the next page and do them. Your teacher will hand out the worksheet for you, and it should look like this. Okay, the what's missing worksheet. Cool. Thank you, students, for watching the video. Have a great lesson. Let me know if you have any questions.